for our next unit, we're going to start simplifying and solving rational expressions. So to start with, a rational expression with that ratio in there is the quotient of two polynomials. So you're dividing. So you have some type of polynomial on top, some type of polynomial on the bottom. Now remember, a polynomial can have any number of terms. You can have one term, which is a monomial, 2 is a binomial, 3 is a trinomial, and anything 4 or more is just a polynomial. So it's anything on top and on bottom. So basically we're looking for variables on top and bottom for the ones that we do. So a rational expression is in simplest form when the numerator and the denominator have no common factors other than 1. Just like a normal fraction, whenever we solve something, if I got down to 4 over 6, I wouldn't leave it as 4 over 6. I would simplify it and get 2 over 3. That's what we're going to be doing now, except all the ones we're going to look at are going to have variables in them. So to get a rational expression in simplest form, you got to factor the numerator completely using all the different ways we've learned of factoring, and then factor the denominator completely, and then cancel out any common factors. So for example, if I end up with x times x plus 1 over 3x times x plus 1, I have an x on the top and the bottom that cancels, and then I have an x plus 1 on top and bottom that cancels, so this one would just become 1 over 3. So we're trying to factor and look for something that's on the top and on the bottom so that we can cross it out. So for the first example, I've got 5x minus 10 over 5x. Well, always look for a GCF first, and 5x minus 10 both have a 5 in it. So if I take a 5 on the outside, I'm left with x minus 2, and then on the bottom, 5x. I can't simplify x minus 2, and I can't factor anything out of 5x, but I do have a 5 on top and bottom. So then my answer ends up being x minus 2 over x. Now you can only cancel out factors, and factors are what multiply to get something. So just because I have an x on top and bottom doesn't mean I can cancel it, because this x is part of x minus 2. So the only thing that will cancel this x minus 2 is an x minus 2. So you can only multiply with or cancel out what's being multiplied. So for the second example, we've got y squared plus 3y plus 2. So up top I've got a trinomial. And it's a plain Jane trinomial because my coefficient's 1. So I want to multiply to c, add to b. So I want to multiply to 2 and add to 3. And so my only factors of 2 are 2 and 1. So that's going to be y plus 2 times y plus 1. Then on the bottom, I've got y squared minus 1. So I've got two terms and subtraction, and y squared is a perfect square, 1's a perfect square, so I'm going to do difference of squares. So the square root of y squared is y, square root of 1 is 1, and then my pattern is y plus 1, y minus 1. So the one thing that I do have in common is y plus 1, so I can cancel both of those out, and I'm left with y plus 2 over y minus 1. Again, I can't cancel my y's because this isn't just y, it's y plus 2. And that's not the same as y minus 1. Alright, again, look for GCF first. So I've got 2x squared and x. They both have an x in common. So that becomes x times 2x plus 1. And GCF on the bottom, they both have an x in common. So that becomes x times 3x plus 2. My x's cancel, and I'm left with 2x plus 1 over 3x plus 2. Alright, on top, I don't have a GCF, but I do have two terms with subtraction, and a squared is a perfect square, 9's a perfect square, so I can do difference of squares. The square roots are a and 3, so I'm going to have a plus 3 and a minus 3. And then on the bottom, I've got a plain Jane trinomial with this 1 out front. So I got to multiply to negative 15 and add to 2. So my two numbers that are going to give me 15 are 5 and 3. I need the 5 to be positive and the 3 to be negative to get to a positive 2. So on top and bottom, I have a minus 3, so it cancels. And I'm left with a plus 3 over a plus 5. In our last example, I have x minus 4 and 4 minus x. These are very close to being able to cancel, but I have, the different order. So normally we want to write it with our x first, so I'm going to rewrite the bottom one so that the top one stays x minus 4. The bottom one becomes negative x plus 4. Okay, again, super close, but all my signs are opposite. So the way that we fix this, or the way we work this problem, is we take out a -1 on the bottom so that I start with a positive x. And when I do that, I'm left with x minus 4 on top, a negative out front, and that's going to make this a positive x and a -4. So anytime it's close but the wrong order and we have the same sign here, just flip it and take out the negative. It's going to cancel, and I get 1 over -1, which is just -1. Now, if you recognize this pattern, you can skip straight to -1 every time. So if you have the same two terms just backwards and the same sign, that means that it's going to be -1.